Hello and welcome to the Extended Greg YouTube channel. I'm Greg, and on today's show we're going to be taking a look at security for the Alpine Linux installation we have on the Raspberry Pi. Let's go ahead and get into it. So pretty much what we're going to be doing today is just kind of doing a brief overview of exactly what kind of things we can do to lock down and secure the system to make sure that our files and also our system itself is safe, because we may have critical data on there, we may have something that we want to preserve, and we don't want it to be put in a situation where it's exposed because we left things open that people could exploit, or what's called attack surface. So pretty much we want to make sure that we're making everything as secure as possible, but also still maintain the functionality that we need. So as far as what's generally used in the IT world, there's something called zero trust, where you assume everybody's trying to attack you, and you go from that kind of perspective. Because if you assume nobody can be trusted, then it's going to be a lot harder for people that you actually don't trust to be able to do it. And people that you do trust, will be able to prove it and will be able to get the access that they need. So first, Alpine Linux is actually a very secure operating system by default because it's a minimalized operating system. It's very small. If you watch the installation video, things like that, you'll see that it is very quick to install and very quick to be able to load and everything else like that. And it's running from RAM. So already we got some points working in our favor because it's working off of a read-only file system. All changes are discarded when it's rebooted. And then also, there's not a lot of things running that could potentially have flaws in them that could be exploited. So already we got some good things working for us, but we have packages that we install as part of what we're trying to make it do useful work. We're going to have packages that we install, so we want to make sure that those are up to date. So the way that we do that is by using APK. So APK, and usually when we've added packages in the past, I'm not going to cover in detail adding packages here just because we don't really have anything to add, although we will go through it a few times. But in short form, you add the packages that you need. But if you need to delete packages that you have because you're no longer using them or they're no longer required, that's apk-del is the command for that. So let's say we want to install something arbitrary. Something we're going to be using a little bit later down the line is something called iptables. So let's actually go ahead and just pre-install that right now. Okay, we see it just installed it. If we wanted to remove it, we would do apk-del iptables. And then it would purge out the configuration and also the executables that are actually utilized for that. So it definitely is a good way to clean up after yourself and make sure that everything is working as expected. If you wanted to actually see a list of what packages you currently have installed, you would do apk info -v, which makes it verbose. And then because we want it to show up in alphabetical, we would put this, which is above the backslash. So it's what's called a pipe. And that's the way you can redirect output into another process. And the process that we're going to run it into is sort. So that way it shows it alphabetically. It just makes it a little bit easier to be able to look at it. And what we see here is if we actually scroll through it, we have the Alpine base image, BusyBox, Crony, E2FS progs, which is what we used to format the last time in the last video. And then IF up down, quite a few packages in here. And we have rsync. So quite a few things, and we would scrutinize this list in order to be able to determine what we needed and what we didn't. And from there, we could actually remove it and strip it down to be even lighter weight than it currently is in its present state. And even if we do apk update, just for example, we see that we have a couple of packages, or we have 19,357 packages, but what happens when those packages get updated on those repositories? we want to be able to make sure that we're staying up to date with the packages that we have installed. So even if we do need them, we want to make sure that they're the latest version. So in case they had features added, or if they had more specifically security fixes implemented, that those are actually up to date on our system. So we would do APK update in order to get the latest list. And then we would do APK version, which will tell us what can be updated. And the way that we would actually update that, and we do see that there's about 7 packages here that can be updated. So it's saying it's 3.18, 3.18.0, revision 0 is less than 3.18.4, revision 0. So that's how you read that. And the R is just a revision. So like here we see OpenSSL has a Rev 4. It may have quite a few 3.1s, release candidates, things like that, that they may denote with that. So, and a lot of times you do see that because some of those packages get really complicated. So they don't want to say it's a new version. They just want to say it's a different variant of that version. So go figure. But here we see that we have 7 packages that we can update. So what we can do is do APK upgrade. And what this is going to do is it's going to install those 7 packages in order to bring them up to date. So now that we brought it up to date, because we have LBU installed, right, and we're making it so we're storing a copy of this configuration locally, and it's going to reload it every time it reboots. If we were just to reboot right now, it wouldn't know that those packages were updated, right? Because we're just working off of the RAM installed version of the system. So we would have to do LBU commit, and then I usually like to do -d, so I'm getting rid of previous versions. So now it's saved to the drive, so it will start up with this. But we also want to make sure that our cache is up to date. So now all of our packages are up to date. So if we do APK version, once again, we see that there's no entries, so everything is up to date. So what we can do APK cache clean, which will remove old packages. And we can also do APK cache sync just to make absolutely sure that all of the packages that we have on our boot medium will actually be the ones that we need in order to make everything work. You can run into circumstances where if you do upgrade and you do, for example, APK cache clean, but you don't do LBU in order to save it, that you would run into a situation where you would delete the package that's referenced by your LBU configuration, and that can cause some problems. So make sure you do this all in one shot. It just makes everything easier. And if it makes you feel better, do LBU commit once again after you run everything, just to make sure that you're saving the current configuration and everything is in sync with each other. So that's the big thing with APK. And the next thing you should look out for in terms of securing your system is users. Everything would be a lot more secure if computers didn't have any users. But actually, we say that, but computers can probably hack each other much better than people. So, I guess it's a trade-off. But we covered creating users in a previous live stream. So be sure to check that out if you want to see how to create those users. And I do reference some things in regards to, what best practices for securing that, things of that nature. But I do just want to highlight once again, and I'm just going to touch on it here since we kind of covered it more in depth in that video, is just chmod is your friend. So to cover the syntax once again, I'll just clear the screen to make it a little easier to read. So chmod, and then you would put in what number you want to do here. So 7 is, so it's user, group, and then everyone else. So that's what the numbers mean. And 7 means that there's full access. 5 means that there's read and execute. And 5, of course, again, means read and execute. So that means anybody can see it. But we could also do 750, which means the user who owns the file can have full access to it. They can delete it, they can write it, they can read it, and they can execute it. And then everybody in the same group can just read it. And then nobody else can do anything to it. So they can potentially see that the file name exists. I mean, if it's a folder, they won't be able to see what's inside of the folder, but they'll be able to see that the file name exists, but they won't be able to open it and do anything with it. So it's just a very good way to be able to make sure that you keep people's hands off of it, so they're only modifying the appropriate files that they're supposed to be modifying. So if they don't need write access to it, you don't give them write access. And you would just finish up this command by putting the path to the file. Right, and I'll just escape out of this. And let's just do another one, which is chown. So we just referenced that those three positions, the 750 refers to user, group, and everyone. So how do we define what the user and the group is? We would say new user. So in this case, it is user : group, and then the path to the file. And again, I cover this in more detail in the user in setting up users in the live stream that we did previously. So I'm not going to do it again here, but just wanted to highlight that that is something very useful for setting up security. So the next thing I'm going to cover is just kind of how to secure shell and SSH, which is what we're using here. We're using PuTTY to be able to administrate this over an SSH connection, which is very useful for network servers, things of that nature. You don't want to necessarily have a keyboard and monitor plugged into everyone, not to mention if they're on the other side of the country or somewhere else in the world. You want to make sure that you can still access it securely, but you don't want to have to hook up a keyboard and monitor to it. So how do we secure shell? So first thing we're going to do is let's go in and edit our /etc/SSH/SSH d config. I'll get rid of the second slash, but it actually doesn't matter. Just if you accidentally type 2 slashes in a row, it actually thinks of it as one, just in Linux. So we click into here, and this is the config file that defines our operating parameters for the SSH daemon. That's what the D stands for. And that just means it's a running service. So as we go through here, there's two major settings that we want to set. Okay, first one is permit root login. We would want to set this to no. And then the second one is password authentication. Which is somewhere here. So let's see if we can find it. But I will tell you this. So all of these lines are actually commented out with the hashtag. And what that means is that they're not actually active within the script. So if you find that there is no entry that is here that is what you want it to be, you can actually just type it. So let's say we want to just go right below here. I'm going to insert, and I'm going to do password authentication. Right, and then we'll do no. And what that means is that you can only use a key file, so an SSH key file, which is the same type of thing that we generated in the user video. That would be the only way to log in. And especially if it's going to be on the public internet, you want to make sure that this is definitely set to no, and that also permit root login is also disabled, because that's one of the most common attack vectors, is an unsecured SSH terminal that has a plain password, a short password. Realistically, they're just going to continue bombarding you once they find an open port, and they're going to figure out that password in not that long, in usually a matter of, weeks, if not days. So it's very important to make sure to lock down this vector. And once again, because we're logged into this is on my local network. I'm going to keep these unset, but once again, this is not a secure system. This is just a dev system. But had we made those changes, the way that we would actually commit them is, or apply them to the running service, is we would restart the service. So we would do /etc /init.d /sshd restart. And there we go. The current settings are there. It would also flag if there was an issue with the SSHD config. But if you're actually logged in through SSHD, take the extra time and make sure that your syntax is correct, because when you restart it, it may actually prevent it from starting. And that could cause some problems for maintaining remote access to it since you're currently using it. And I will say this as well. Anytime that you change the configuration file for SSHD or change other things like firewalls, which we're going to be covering next, you want to make sure to open up a second session before you close your existing session. Reason being is that there's different rules for services that are already in use. So for example, with our current open session here, it will follow the rules that you had when you logged in and not necessarily follow the new ones. So it could leave you time to be able to correct errors without having to completely go and physically connect to the system. So just a good little tip right there. You want to make sure that you're working protectively so you're not locking yourself out of your own system. So going on from here, firewalls. So firewalls are very important, especially for public-facing systems. Alpine Linux is very lightweight, and it's something where it's commonly used in Docker, and also if you just wanted to create a very lightweight web server, things like that, it's a very good use for that. But you don't want to just leave it as it is stock on the internet. It is pretty secure by default, but the problem is that it will do things like respond to ping commands. It will give a lot of indicators to hackers that things are available to be able to try to exploit. So you want to make sure that you're actually going through it and locking that down. And the best way to do that is by using a firewall program. And in this case, we're going to use iptables. So we'll do apk add iptables. Spelling counts. And that's going to install the iptables. It's very lightweight once again. Again, we only have 23 megabytes of packages installed, so it's not much at all. But what this will do is this will actually allow you to be able to reject packets and drop packets based on rules that you define. So let's set a few rules. So the first thing that we're going to do is actually set our default rules. So we're going to do iptables, all right, -p for persistent, or I think that's persistent actually, don't quote me on that, but -p, because this is the, policy I think is what it stands for default policy. Let's look. Oh, it didn't like that. It's giving me the help file for greep. All right, whatever. Oh. So what it did is it's actually outputting it to standard error instead of standard out. So the pipe command to greep didn't work. So we would have to do 2 caret and ampersand 1, and then we could do our greep. and it still doesn't like it. So you're going to have to trust me. You can look it up on your own, but iptables, let me clear this. iptables dash capital P, and then input drop. So input is the actual list that we're adding this to. So it's for incoming packets from the outside. So our default action is when they come in, we want to drop them. Because if they're not assigned to a rule, it's going to hit this default case. And that's going to mean that we want it to disappear. We don't want to respond to it and tell it that it's not allowed. We want to just be a black hole on the network where we reside. That way they don't even know that there's a computer there. So we'll add that. Next is iptables. Oh no. Oh, I locked myself out too soon. No, it did work. Did it? No. Just a moment. So what just happened? So it just reset our connection because it turns out it was actually already running. So technically speaking, you're supposed to have to actually add it to RC and then run it, but that's okay. And we didn't save anything, so we're still good. We just rebooted it, and we're just going to log in and try it again once it comes back up. Assuming it does. That would make for a fun stream if it locked me out of the system. All right, so we're here. I'm going to reinstall iptables. And just so we can look at what the current list is. So we're going to do iptables list. And it shows us that we have absolutely no policies defined. So before we do anything, let's see what our service status is. So we're going to do /etc /init.d /iptables, and we're going to do status. It says it's stopped. So the reason why it locked me out is beyond me, but that's fine. And we're just going to keep it simple. We're going to do these in a slightly different order, which are probably a bit better. But generally speaking, you don't want to have it in a state where it's reading your actual changes on the fly because you'll have partial changes applied. So just something to keep in mind. And again, I do like Alpine because of that, because I was able to reboot it and abandon those changes that caused a problem in the system. So first, we're going to add our forwarding ports, our forwarding rules. So let's do iptables -a for add input, which is our list or the chain. So we see here, we see our chain input policy accept, chain forward policy accept, chain output policy accept. So, oh, and that's what the capital P stands for, is policy. That makes sense. So short form is, right now it's set to accept everything. So anything that knocks on the door, it's going to let in. All right. And that's going to be the worst case scenario that you could possibly have for a firewall. If it doesn't block anything, it's not a very good firewall. It's really just a switch. So, you know, we want to make sure that we're setting it up. So the first thing we're doing right now is we're adding our permissions for things we do want to let through. And you guessed it, we're adding the port for SSH. So what we're doing is we're adding TCP, because it's TCP communication. The two options really are TCP and UDP for general traffic. We're using port 22. Data port 22 is what dport stands for. -J, I don't know what -J stands for off the top of my head. And then accept. So the action is that we want it to accept it. And I'm not sure why they chose J. And What did I miss? Let's see. And hopefully I'm not going on an old syntax here. So we go up here. Bum, bum, bum. Right, dash A. Chain, rule specification, and options. Dash A, input, port TCP. Actually, I'm not sure if it needs the dash J. Nope, J is target. Oh, jump. Right here. That's good to know, but still not really useful. So let's see what we got. I'm just going to hit it once more, and it just says bed argument 22. So it doesn't like the port number. Let's try putting it in quotes. Oh. So minor typo on my part. I didn't do a double dash. So you do single dashes for the single arguments, single letter arguments. So like the dash A and dash P are single letters, dash J. So you put the single dash for those. But when you do double dash, that means that it's multiple letters spelling out a word or a keyword. So because I put the single dash, it didn't know how to interpret this particular flag. And that's why it was erroring out. Okay. Sanity check confirmed. You know, it's there. So now if we do iptables list with 2 dashes, we do see that it is currently accept, the target is accept, the protocol is TCP, no options, the source can come from anywhere, the destination can be anywhere, although generally speaking the destination is going to be the local machine. And then it's going to be TCP for the service SSH. So that's how we read it, but now we're allowing it through. So now if we do iptables -p input drop. Okay, we got there, and we can still do things now. If we do iptables list, we see that the policy, the default policy here, changed where it was previously accept. And actually, I think this does show up in one screen. So it changed from accept to drop, right? And we're going to repeat the same exact thing for everything else. Except I will say this, output's pretty much going to stay the same, but we are going to type in the command and define it as a matter of best practice for our own purposes, just to make sure. So we'll do iptables -p, capital P, forward, drop. Right? So if it asks us to forward anything to any other machines as like a relay point and we don't want it to, we will tell it to drop that traffic and just be a hole on the network. We'll confirm it again. We see default policy has changed right here to drop. And the last one that we're going to do is our output. And because we want to be able to access the internet generally, we're going to do iptables -p output accept, right? Because we want to be able to create the connections because we're already inside the machine. So we want to be able to get out of it to get to our network. And there we go. So we have our default policies defined. And for the purposes of just adding one more that we're going to use in a second, if we had a web server running on this machine, we would actually want to be able to forward port 80 as well, and maybe 443. But in this case, let's say it doesn't have encryption, so port 80. So we'll do iptables dash A, capital A, input dash P, TCP dash dash dport 80 dash J accept. There we go. So this is our current firewall table for iptables. So anything that is not port 80 or port 22 will be dropped on the incoming direction. And that's going to keep us very much more secure, because then if our attack surface is only those two ports, and we're not reliant upon the operating system identifying the fact that there's no service there to actually respond to any kind of traffic that is not on those ports, or on a port that doesn't have a service attached to it. So as far as these two right here, let's run with it. So we're going to save these, right? And we're going to do /etc /init.d /iptables, and we're going to say save. Right? So where it saved it was /etc /iptables /rules save. And what that means is the next time we start up, it's going to load these rules back into iptables and use them. But of course, we just saved something to the hard drive. So what do we have to do for that is lbu commit, because we want to make sure that we save it as part of that. So now it's saved it saved into LBU the fact that we installed iptables, as well as the fact that we saved our configuration out. And the other thing we want to do is we want to make sure that we're starting iptables on boot. So we would do rc update add iptables. Right? Now, we don't actually want it to run on default, so I'm going to del that really quick. We want to add it on boot, so we're going to define that. So iptables boot, because we start our network on boot. So we want to start it at the same time as our network starts. So now we see it started at run level boot. So now we've added everything. We have our iptables up. We can start it /etc init.d /iptables start. Right? And now it's started. So we can actually do the same thing again and do status. And we see that it is started. So it's using our current iptables config, plural. It's using this config as we speak. So our system is already a lot more secure. Obviously, if you don't start it, it's not going to do you much good. So let's say we uninstalled our web server, and now we wanted to remove that entry since we're no longer going to have a service that's actually there to respond to it. The way that we would do that is iptables -D for delete. And then what we would do is we would define what chain it's associated with us. In this case, it's input. And then we would give it the number from the top, right? So this top line right here, which is SSH, this is line 1, and here we see it on line 2. There are other ways to delete it as far as retyping in all of the parameters associated with it, but I find that this is just easy enough if you only have a short list. If you have hundreds and hundreds of lines, this may not be as easy. So we're going to do input 2, right? So now when we list it again, we see that it is no longer present. So we only have the SSH command present, but our HTTP command, our HTTP rule is no longer present. So now we would follow the same thing, and we would save it out to disk, and run lbu once again. Perfect. So the state is saved. Now we do lbu. If we looked at diff, I'm trying to see. So we have iptables listed here. We have our rules save. So we do see that the changes that are present are related to iptables after we save that. So if we don't save this, none of those changes will be saved. And then we do lbu commit. And again, I'm doing -d to clean up. So now we're pretty much all set. And we could restart iptables as well. So /etc /init.d /iptables. I don't believe that this is actually required, just based on my last recollection. Let's see. Yeah, but we could do restart as well, just to make sure that the current routing table is reflected. But generally speaking, from my experience, it's been instantaneous. As soon as you actually make the changes, they apply immediately to the running config. It's only when you reboot that you actually will see whatever your last saved config was. So, but if it makes you feel more comfortable to restart it, you can restart it. Just, make sure your config is correct. Now, I will say this, when it does automatically load, it will keep the current running config in the event that the configuration is invalid. So, that's something useful to be able to protect yourself from accidentally getting logged out because you changed something, that wasn't going to work. So it's a very useful application, and it's something that actually is cross-platform on pretty much all Linux distributions. But it's very common for web servers, especially, where you're going to have a lot of people who know your IP address. You have domains associated with it, and you don't necessarily want them, powering through and just finding open ports to exploit. So, going from there, let's take a look. So, the next thing is if you want to make sure that make sure that you don't have any unused services. So if you have services that you're not actually requiring for whatever you're using this machine for, you want to actually disable those or delete them. So, obviously you can do rc status, and you can get a full list of things that are available, or installed on the system and what their current running state is. So we can see under run level default, we have cron d, ACPID, which looks like it crashed, crony-d, which is our time service, SSHD, and update MOTD time, which is one that we created previously. And then from there, there's a number of additional services associated with it, and also run level boot, for example, is not displayed here. So if we saw something that we didn't need, we could do rc service, the service name, and then stop, right? Or we could do it like we were, which is /etc /init.d / the service name, stop as well. And then if we wanted to delete that service so it wouldn't run automatically anymore, we would do rc update del, and then we would do the service name like iptables if we wanted to for whatever reason. And that would remove the service so it would no longer start from wherever it was. And then from there, let's go through a few other things. So the next thing is we want to make sure that we know where the logs are. I don't think we've gone much into logs before, but there's a very nice utility called tail that allows us to be able to look at the logs live. So if we do tail and then we do -f, that will constantly refresh based on what updates are happening to a particular file, in this case log files, and then we can just put the path to the file. So we would do /var /log, and then we have a few options that we can go through, like messages, things like that. On other Linux systems, you'll have things like syslog and things like that here. And in our case, we would actually have to install that, but that would give us additional insight in regards to what's happening with the system. So like automatic running services or other types of processes that would, if they have errors or things like that, we would be able to see that within these logs to be able to determine. So let's take a look at Crony's log. And it doesn't have anything because it's never had an error. This doesn't have it. Let's just do messages. There we go. So we see that this is keeping track of our cron process, right? And this is very similar to our syslog as well. My cat is here again to say hello. But what this is going to do is, as every time that it actually goes through and a change occurs on this file while we're in tail-f mode, it's going to actually update the screen live. So we don't have to reload it, we don't have to rerun the command. So we can see, for example, we updated a boot service here, which was when we restarted iptables. She wants to say hello. It's Nala. So pretty much it's saying like cronid can't synchronize, no selectable sources, things like that. So it may have an issue with, for example, the actual sources associated with the cronid configuration. So something to keep in mind. Oh, and Pavan Kumar, I see, says, love your Alpine videos. Thank you so much. I appreciate that. So, and thank you for watching as well. So, as far as everything else from there, you know, that's logs. And to exit this, you would type Control-C. So, pretty much the last two things I'm just going to mention briefly, because we haven't really gotten into Docker images and things like that. But Alpine Linux is actually very common for Docker. And, you know, this is often where you see things like web servers and things like that that you have to lock down. So it's very important to definitely keep zero trust practices in play if you're going to deploy anything live. And Docker is definitely a good way to do that, but always keep it minimal. You know, the fewer packages, things like that, that you have installed on your installations, the better it's going to be able to actually keep everything that you do know about and you are intending to have on there secure. So just something to keep in mind. And I think we're going to cut it off here for today. I was going to talk about backups, but I'll actually cover that in a separate video. I think this live stream's getting long enough. So thanks for watching the video today. If you liked the video, be sure to hit that like button and leave a comment down below. And if you haven't subscribed, please subscribe. It helps me out a lot. And don't forget to hit that notification bell. That way you know the next time we're getting extended. So until then, take care. Oh, and don't forget to share this with a friend. Thanks. Take care.